we're going to talk about how you can handle making Cartesian equation from parametric equations. Parametrics, you've often got these on your hands if you have two separate equations where one is x equals y equals with t, where t is not just some sort of unknown mystery number. It's actually a parameter. It's a variable. It's something that changes, okay? And how t changes affects how x changes, and how t changes affects how y changes. So they sort of go their own separate ways and sometimes come back together when you draw them. You get all kinds of weird and wonderful graphs if you use them. So how do these questions normally go? Well, when we can see t being used and we're sort of multiplying or squaring or something like that, the general strategy is as follows. Yeah, make one equation into t equals. So sounds obvious, but is not always appropriate, as you're going to see on the next example. Now, if it's Cartesian, all we have to do is we just have to have y's and x's, okay? It doesn't even necessarily need to be y equals, although if it is, they'll often say y equals f of x. That's how you know that they want you to get y on its own. So let's have a go, and let's just do whichever one seems slightly more convenient. So now the y, it's a bit more complicated, so I will actually do x minus 2 equals 3t. And we're going to just do x minus 2 over 3 as our value of t. Where's this one going to go now then? Well, that one is going to go into this t here. So if we want to be very, very careful when we substitute out, we write y equals 5 plus 4, and the thing we're going to sub out goes squared. That's this result now going in. So let's do x minus 2 over 3. Okay, so y equals a 5 plus, let's do the powers first, please. So 5 plus 4. Let's just put all of this in brackets in the meantime. So I'm going to do x minus 2 squared and leave that as that just for now, over 9 equals 5 plus, there's a lot of different things we can do here. How about doing something like this? 4/9 x minus 2 squared. Okay, and you know, this is Cartesian, okay? In fact, technically, it was really Cartesian from this part here, okay? It's just that we may have to do some final things, and they'll often tell you how they want you to do that if that's the case, okay? So, you know, we might have to work that forward to some desired form. Now, on this one, then, we have to do something slightly different. So, theta can take any real value, okay? Theta is not always just a mystery number. Theta is the second most common, really. T is the most common, and the theta are most common in parametric questions at A-level for these sorts of questions. So our strategy here is going to be a different strategy. Our strategy here is going to be use identities, and again, it's going to be to eliminate the third parameter, in this case, to eliminate theta. So the thought process needs to be like this. What identity do I know that has cos and sine in it? Cos and sine, and maybe just, apart from that, just, you know, constants. So what I like to do is, now, and I know this is not the most difficult example, but it's just in general, this is what I would always do, is I will write down my identity first. Okay, I'm going to put equals 1 instead of identical to 1. And then I will assemble the pieces ready so that they match before I sort of, you know, try and do loads of work. So what do I mean? So I mean, over here, I'm going to do x equals 4 cos theta. I'm going to do x over 4 equals cos theta. And then I'm going to do, you know, x squared, this will be x squared over 16 equals cos squared theta. I'm going to get the piece ready. And at the same time, I'm going to do y equals 2 sine theta, y over 2 equals sine theta, and y squared over 4 equals sine squared theta. So I'm getting the sine squared piece ready. And I'm also getting the sort of the cos squared piece, getting that ready as well. And then they're just going to go into this suited by identity once I've made them appropriate. So it becomes x squared over, I'm just checking I'm doing my, so key skill for A level here, checking back over your work as you're going. So actually that was y squared over 4 over here. There's the plus sign. That's x squared over 16. And that's just equals 1. Nice trick here would be to multiply by 16 on both sides, which would give you 4y squared plus x squared equals 16. Okay, if you're interested to know what shape this would be an ellipse. It's Cartesian though, because we've managed to eliminate theta. So if we are sort of adding, multiplying, subtracting, dividing, you know, powers and, well, also sort of e's, natural logs, things like that, this tends to be the way to do it, okay? Getting t on its own. If we are working with trig, especially trig, okay, identities really are what we're looking for. They can be sine squared and cos squared. They can be things like sec squared plus 1, tan squared plus 1 equals sec squared. You know, check out some of the other videos if you want to get an idea. But assembling the pieces and then substituting them in really does make this very, very easy and very hard to drop any marks.